Why some smells send you back in time. Maybe it's a specific soap, a wood fire, cut grass after rain, old books, someone's coat, the inside of a car that no longer exists. You catch it for half a second, and something happens that is not quite memory. It's faster than memory. It hits before you've decided to remember anything. You are somewhere else entirely, another room, another age, another version of yourself, and then it's gone. And you're standing in a hallway or a parking lot wondering what just happened. That wasn't nostalgia. That was something older. Your nose is the only sense on your body with a direct line to the past. Every other sense you have, sight, sound, touch, taste, sends its signals to the thalamus first. The thalamus is your brain's relay station. It receives the input, processes it, and routes it. By the time you consciously perceive anything, the information has already passed through several layers of filtering. Smell skips all of that. When an odor molecule enters your nose, it binds to receptors in your olfactory epithelium. Those receptors send signals directly to the olfactory bulb, and the olfactory bulb connects immediately to two structures, the amygdala and the hippocampus. The amygdala handles emotion. The hippocampus handles memory. No other sense has that shortcut. Vision doesn't have it. Sound doesn't have it. Smell goes straight there, bypassing the filter entirely, landing directly in the part of your brain that decides how you feel and what you remember. This is why a smell doesn't just remind you of something, it returns you to it. Scientists call it the Proust phenomenon. In 1913, Marcel Proust wrote about dipping a Madeleine into tea and being transported so completely to his childhood that he described the experience as recovering lost time. For a long time, it was treated as exaggeration, but it wasn't. In 2004, researchers at Brown University found that odor-evoked memories are older, more emotional, and more vivid than memories triggered by any other sense. And the gap is humongous. When subjects were asked to rate how much a memory felt like they were actually there, smell-triggered memories scored higher than memories triggered by photographs, music, or direct verbal cues. A photograph of your grandmother's kitchen is a memory about the past. The smell of her kitchen is the past. Your brain doesn't process them the same way. But the question is why? Why would your brain be wired this way? Why would smell, of all senses, get the direct route? The answer is time. Smell is the oldest sense you have. Not the oldest in your lifetime, the oldest in evolutionary history. In creatures that existed hundreds of millions of years before you, before sight was sophisticated, before hearing was refined, smell was how animals read the world. The first nervous systems that existed in early vertebrates were essentially smell processing machines. The entire brain as it first appeared was built around chemoreception, detecting chemicals in the environment and generating a response. Over hundreds of millions of years, everything else grew around that original structure. Your olfactory system isn't just ancient, it is the foundation the rest of your brain was built on top of. And because the olfactory bulb predates the thalamus by hundreds of millions of years, it never got rerouted through it. It still runs the old wiring, the original connection. When you smell something, you are running the oldest software your brain has. Now here's where it gets strange. Odor memories don't just feel more vivid, they decay differently. Most memories fade on a predictable curve. In 1885, German psychologist Hermann Ebbinghaus mapped it out. You forget roughly 50% of new information within an hour, 70% within a day. Over time, the memory smooths out, loses detail, becomes a general shape of an event rather than the event itself. Odor memories don't follow that curve. The memory of a face changes over years. You lose the specifics. The memory of a smell comes back at the same intensity it was encoded, sometimes 50 years later. You don't just go back in time. You go back to a version of yourself that no longer exists. A self that had no context yet for what life would turn into. For a fraction of a second, that self is available again. And then it isn't. There's a practical reason your brain does this that has nothing to do with nostalgia. For most of human history, smell was survival. The smell of smoke meant fire, and fire meant danger or warmth depending on context. The smell of rot meant food that would make you sick. The smell of a predator's musk in the undergrowth. the smell of rain before a storm, the specific chemical signature of a safe place versus a dangerous one. Your ancestors could not afford to let those signals pass through a relay station and risk being delayed by a fraction of a second. In the environment that built your brain, a half-second gap between smelling a predator and responding to it could mean death. Direct wiring was a survival mechanism. The fact that it now sends you back to a summer from 20 years ago, when you smell sunscreen, that's not what the system was designed for. That's a side effect of encoding so powerful it outlasts its original purpose. Your brain built the most direct neural route it had to the things that mattered most. And it still uses that route, even when there's no predator, even when there's no fire, even when all it finds at the end of the line is a child standing in a garden that no longer exists. There's one more thing. Smell is the only sense that degrades before the others in Alzheimer's disease, before memory goes, before language goes, before recognition goes. The ability to identify odors begins to fail years earlier. In some studies, loss of smell has been used as an early diagnostic marker. What that suggests is that the olfactory system is so deeply integrated with memory that when memory begins to unravel, it takes smell with it. Or maybe smell goes first and memory follows. The connection runs so deep that researchers still aren't sure which direction the damage travels. The sense that can send you back 50 years in an instant is also the first thing to go when the mechanism of memory begins to fail. Tonight, something will catch you off guard. For a moment, you'll be somewhere else entirely, a place so specific and so gone that you'll feel its absence like a room with the furniture removed. That feeling isn't imagination. It's the oldest part of your brain doing exactly what it was built to do, still sending signals down the original line, still trying to keep you safe from something that isn't there anymore, still taking you home,